Déjà vu, a memory of the future. It begins without warning. You're visiting a city for the very first time, yet as you turn a corner, the sight of a specific cafe with a green awning under a crooked street sign strikes you with the force of a memory. You know this place. You've been here before. This powerful, unsettling sensation is déjà vu, a phenomenon that over 2/3 of us will experience in our lifetimes. The most straightforward scientific explanation suggests it's a minor hiccup in our brain's filing system. For a fraction of a second, the part of your brain responsible for processing new, incoming information sends it down the wrong neural pathway, accidentally filing it directly into your long-term memory. So for a brief moment, the present feels like the distant past. It's a clean, logical explanation for a profoundly strange feeling. But what if that feeling of deep familiarity isn't a mistake? What if it's a genuine signal from a reality far more complex than our own? This is where the story truly begins. One compelling theory proposes that déjà vu is a brief moment of alignment with a parallel universe. In another reality, a different version of you has already lived this moment, and for an instant, your consciousness resonates with theirs, giving you a fleeting, second-hand memory of their experience. Another, more cyclical view suggests that time itself repeats. In this model, we are living our lives over and over, and déjà vu is a faint scar on our consciousness, a ghost of a memory from a previous playthrough of the same existence, hinting that we have indeed walked this path before. And then there's the most reality-bending possibility of all, that you are not remembering the past, but are in fact remembering the future. What if your mind, for an unknown reason, can occasionally receive a faint premonition, a flash forward of an event you were destined to experience? What you feel as déjà vu is then the moment reality finally catches up to that precognitive echo. This single common human experience, so easily dismissed, acts as a crack in the wall of our perceived reality, inviting us to question whether time is the simple straight road we imagine it to be, or a landscape filled with echoes, loops, and hidden dimensions. The Bootstrap Paradox, the story with no author. If déjà vu is a personal glitch, the Bootstrap Paradox is a perfect, unbreakable loop in the logic of the universe itself. It describes a situation where an object or a piece of information has no origin, existing in a self-contained cycle for eternity. Let's paint a picture. Imagine a brilliant composer struggling to write his final masterpiece symphony. He is completely blocked. One night, an old mysterious man visits him and hands him a complete, beautiful musical score. The composer is stunned by its genius and publishes it under his own name. It becomes the most celebrated piece of music in history. Years later, now an old man himself, the composer is filled with a sense of duty. He takes the original score, builds a time machine, and travels back to give it to his younger, struggling self, thus becoming the mysterious visitor from his own past. Now ask the question, who wrote the symphony? It wasn't the young composer, he just copied it. And it wasn't the old composer, he was just returning what he had received. The masterpiece had no creator. It was never written, only passed along an endless loop. This is the Bootstrap Paradox. It completely defies our understanding of cause and effect. Everything we know, from a simple chair to a complex idea, has a point of origin, a moment of creation. This paradox suggests that the universe might allow for acausal objects, things that exist without ever having been created. They are their own cause and their own effect. This opens up a strange and unsettling line of questioning. Could Shakespeare have been given a copy of Hamlet by a time traveler? Could Leonardo da Vinci's most brilliant inventions have been based on sketches he received from the future? The paradox challenges the very foundation of human creativity and invention, suggesting that some of our culture's most foundational elements might not have a beginning at all, but are simply echoes of themselves, forever pulling themselves up by their own bootstraps. The grandfather paradox, the ultimate contradiction. From a loop that has no beginning, we now turn to a paradox that threatens to create an impossible end. This is the most famous thought experiment in all of time travel, a logical checkmate that seems to forbid anyone from ever changing the past. The story is a classic for a reason. You build a time machine, fueled by the desire to right a past wrong, or simply to see what came before. You decide to travel back in time by several decades, to a point before you were ever born. You locate your own grandfather when he was a young man, before he had the chance to meet your grandmother. Then, whether by accident or by design, you do something that prevents them from ever getting together. The immediate, logical consequence is that one of your parents is never conceived. And if your parent is never born, then you, in turn, are never born. And here is where reality shatters. If you were never born, you could never have grown up to become a brilliant inventor. You could never have built a time machine. And you certainly could never have traveled back in time to interfere with your grandfather in the first place. The very act of successfully completing your mission makes your mission impossible from the start. It's a statement that erases itself. For many scientists, this paradox implies that the past must be unchangeable, protected by what's called a self-consistency principle. The universe, in this view, will simply not allow such a contradiction. If you tried to interfere, you would be met by a series of strange and improbable failures. Your equipment would malfunction at the critical moment. You would be delayed by a sudden traffic jam. Or, in the ultimate ironic twist, your very attempt to stop them from meeting, perhaps by heroically pushing your grandmother out of the way of a speeding car, would be the very act that introduces them and causes them to fall in love. In this view, the past is a solid block, and you are not a visitor who can change it, but a part of it that can only play your destined role.
Parallel timelines, escaping the paradox. So, if the grandfather paradox creates a situation that logically destroys itself, how could time travel ever be possible? The universe might have an escape clause, a solution so elegant and mind-boggling it transforms the very nature of reality. This solution is known as parallel timelines, or the many worlds interpretation. Imagine time isn't a single rigid highway that everyone travels on together. Instead, imagine it as an infinitely branching river. Every time a decision is made or a random quantum event occurs, the river splits, creating new streams for every possible outcome.
Now, let's return to your mission. You traveled back in time and successfully prevent your grandparents from meeting. In that critical moment, you don't simply vanish in a flash of light. The universe doesn't crash. Instead, your action forces the river of time to fork. Your original timeline, the one where you were born and built your time machine, flows on completely unharmed. In that reality, you are now a missing person who mysteriously vanished one day. But your interference has just birthed a brand new timeline, a parallel universe that has branched off from the main one. In this new reality you now inhabit, your grandparents never met, and a version of you will never exist. You have successfully changed the past, but the crucial detail is that you haven't changed your own past. You've simply stepped out of your own history and into an alternate one that you created. The paradox is brilliantly solved, but it comes at a staggering personal cost. You are now a permanent refugee, an anomaly living in a version of the world that is not your own, with no way to ever return to the life you knew. This theory suggests that an infinite number of universes are being created every single second for every possible choice, big or small. It means that somewhere there's a universe where you took that other job, a universe where you said yes instead of no, a universe where you never lost that loved one. It offers a vision of ultimate freedom, where all possibilities are real, but also one of profound isolation, where every choice separates us from the infinite other versions of ourselves. The predestination paradox, the illusion of choice. While the idea of parallel timelines offers a sense of infinite freedom, the predestination paradox presents the chilling alternative, the possibility that we have no freedom at all. This paradox paints a picture of time not as a branching river, but as a perfect, unbreakable circle. It argues that any attempts you make to change the past were not only doomed to fail, but were, in fact, always a necessary part of how things happened in the first place. You are not an agent of change, you are an instrument of history. Imagine you discover an old diary that describes a terrible fire that destroyed a historic theater 100 years ago. You feel a sense of duty, so you use your time machine to travel back to that fateful night, determined to stop the tragedy. You arrive just before the fire is said to have started, and you see a flickering lantern left dangerously close to a velvet curtain. As you rush to move it, you stumble in the darkness, knocking the lantern over and igniting the very fire you came to prevent. You weren't an outsider trying to alter events. Your panicked journey to the past was the cause of the fire all along. You were always part of the story. This is the heart of the predestination paradox. It suggests that there is no outside of the timeline. Free will in the context of history is a powerful illusion. From your point of view, you were making choices, but from the universe's point of view, you were simply following a script that was written long ago. This transforms a time traveler from a godlike figure into a tragic one, a puppet on a string who believes they are in control, while their every move only serves to ensure that fate unfolds exactly as it was always meant to. It suggests that time is a self-consistent, solid block of events, and our struggles against what is written are merely the ink that make the words permanent.
Retrocausality, when the future pulls the strings. We live our entire lives with one fundamental assumption. The past influences the present, and the present influences the future. It is a one-way street of cause and effect. But what if that street had hidden lanes flowing in the opposite direction? What if the future could, in some subtle way, reach back and influence the past? This is the mind-bending concept of retrocausality, or backward causation. This isn't about receiving a message from your future self, but something far more deeply embedded in the fabric of reality itself. The strangest evidence for this comes from the world of quantum physics. In experiments like the delayed choice experiment, the way a scientist chooses to measure a particle in the present moment appears to directly affect the physical properties and behavior that the particle had in the past. It's as if the particle somehow knew how it was going to be observed and adjusted its history to match. This shatters our simple linear view of time. Think about what this could mean for us. Could a sudden flash of creative genius be more than just a random spark? Perhaps it's a faint echo of the finished creation, a ripple sent backward in time from the moment of its completion, guiding its own creator. Could a powerful gut feeling or a sense of intuition be a subtle signal from a future event, nudging us in the right direction? Retrocausality suggests that the future isn't a passive destination we are traveling toward, but an active participant in our journey. It might have a kind of gravity, gently pulling on the strings of the present to ensure that certain outcomes are met. It doesn't erase our free will, but it suggests we are in a constant, subtle dialogue with our own destiny, where the past pushes us forward and the future gently pulls us along. Quantum entanglement. Spooky action across time. Albert Einstein was so baffled by this phenomenon that he famously called it spooky action at a distance. It remains one of the deepest mysteries in all of science, and it points to a level of connection in our universe that defies all common sense. When two quantum particles, like electrons, become entangled, they are linked in a profound way. They essentially give up their individual identities and become a single unified system, even if they are separated by billions of light years. Imagine you have a pair of magic gloves. You put them in two separate boxes and mail one to the other side of the world. The moment you open your box and see you have the left-handed glove, you know instantly that the other box contains the right-handed one. There's no signal sent between the boxes. The information is instantaneous. Quantum entanglement is like this, but even stranger. This spooky connection is well proven across vast distances of space. But this leads to an even more profound question. Could this connection also exist across time? Some physicists theorize that it can. This idea, called temporal entanglement, suggests that particles could be linked across the temporal dimension. An action performed on a particle in a lab today could be instantly correlated with its entangled partner that existed thousands of years in the past, or one that will exist thousands of years in the future. This isn't a form of communication.
You couldn't use it to send a message to the past. Instead, it suggests that the universe is fundamentally interconnected in a way that transcends not only space, but also our perception of time as a sequence of separate moments. It paints a picture of reality as a single, holistic entity, bound by these invisible, spooky threads that connect the now to both the then and the what will be.
The delayed choice experiment, observing the past into existence. We tend to imagine the past as being solid, concrete, and unchangeable. It's a finished story that we can read, but never edit. However, a brilliant thought experiment, later confirmed by real-world tests, suggests that the past might be far more fluid and ghostly than we believe, only snapping into solid reality when we look at it. This is the delayed choice experiment, and it exposes the deep mystery of observation. In the quantum realm, a particle like a photon can behave as a solid particle, like a tiny bullet, or as a spread-out wave, like a ripple in a pond. How it behaves depends on how you measure it. If you set up an experiment to see which path it takes, it acts like a bullet. If you don't, it acts like a wave. The genius of this experiment was to delay the choice of how to measure the photon until after it had already passed the point where it should have decided to be a particle or a wave. The results are shocking and profound. The decision made by the observer in the present moment determines the reality of what the particle did in the past. If you decide to look for its path, it turns out it only ever took one path. If you decide not to look, it turns out it behaved like a wave and took all paths at once. It's as if the universe holds its breath, refusing to commit to a single history until it is observed. This elevates the role of consciousness from a passive audience watching the cosmic play to an active participant that helps write the script. It suggests the past isn't a fixed, objective reality sitting there waiting to be discovered. Instead, it may be a shimmering, undefined haze of possibilities that only becomes real and concrete when a conscious observer turns their attention to it.
Time distortion in dreams, a lifetime in a single night. While physicists explore time in the quantum realm, our own minds perform their own reality-bending experiments every single night. We've all experienced it, a dream that felt incredibly long and detailed, a sprawling epic that seemed to span days, weeks, or even an entire lifetime. You can live through complex adventures, build relationships, and watch entire stories unfold, only to wake up and see that just 10 minutes have passed on your alarm clock. This powerful distortion of time is not just a strange feeling, it's a window into the nature of consciousness itself. In our waking lives, our perception of time is anchored by a constant stream of external information, the cycle of day and night, the ticking of a clock, the rhythm of our own bodies. But when we enter the dream state, especially during REM sleep, our brain is cut off from these external anchors. Freed from the duty of processing the outside world, our consciousness becomes its own self-contained universe, with its own rules and its own clock. The brain's altered chemistry allows it to process thoughts and construct narratives at an incredible speed. It can compress what would be years of perceived experience into a few minutes of intense neural activity. This demonstrates that the steady, familiar 1 second per second flow of time is not a fundamental law of experience. It is a specific mode of perception that our brain constructs to help us function in the physical world. Our dreams prove that our consciousness has the innate ability to experience time in a radically different, more elastic way. It suggests that our waking perception of time is a carefully crafted illusion, and that our minds hold the secret to experiencing reality in ways we can barely begin to imagine.
Wormholes, ripping a tunnel through spacetime. Our final glitch is not one of mind or logic, but one of the very fabric of the cosmos. It is the ultimate science fiction dream, a physical gateway through time. According to Albert Einstein's theory of general relativity, space and time are not two separate things, but are woven together into a four-dimensional fabric called spacetime. Massive objects, like planets and stars, bend and curve this fabric, which creates what we feel as gravity. But Einstein's equations allow for a possibility far more extreme than just a curve. They allow for the fabric to be torn and stitched back together, creating a tunnel. Imagine space-time is a vast sheet of paper. To get from one end to the other, you have to travel the long way across its surface. But if you could fold that paper in half and punch a hole through both layers, you would create a massive shortcut. This is a wormhole. In theory, a wormhole could connect two incredibly distant points in space, allowing you to cross a galaxy in the blink of an eye. But because space and time are fundamentally linked, a shortcut through space is also a shortcut through time. If you could create a wormhole and then move one of its mouths at very high speeds, time for that mouth would slow down relative to the other. The result would be a tunnel connecting not just two different places, but two different moments. One end might open in your laboratory today, while the other opens in the streets of ancient Rome, or on a desolate future Earth. While no one has ever found a wormhole, and keeping one stable might require exotic forms of matter we don't yet understand, they remain a genuine mathematical possibility. They represent the ultimate physical cheat code for the universe, a concept that takes all the paradoxes we've discussed, from the self-creating loop to the self-erasing contradiction, and provides a potential, terrifying physical doorway to make them real. Why time feels faster as you age. It is one of the most universal and bittersweet experiences of human life. When you were a child, summers felt like a vast, endless ocean of time, filled with infinite possibilities. The wait between one birthday and the next felt like an eternity. Yet as an adult, you blink and a whole season has vanished. Years seem to fold into one another, accelerating until you find yourself wondering where the last decade went. This isn't just a feeling or a trick of nostalgia. It is a well-documented psychological phenomenon, and there are several compelling theories as to why it happens. The first and most popular idea is based on novelty. When you are young, almost every experience is new. Learning to ride a bike, your first day of school, seeing the ocean for the first time, your brain is in a state of high alert, recording every rich detail because it is all crucial new information. This creates an incredibly dense and detailed memory log. When you look back on these periods, the sheer volume of unique memories makes that time feel long and substantial. As you get older, life naturally becomes more routine. The daily commute, the weekly grocery run, the familiar tasks at work. Your brain, being incredibly efficient, no longer needs to record every mundane detail. It has seen this all before, so it can process your days using mental shortcuts. The memory log for these years is far less dense, and so when you look back, the time feels like it passed in a flash. Another powerful explanation is the proportionality theory. It suggests that we perceive a unit of time relative to the total amount of time we have already lived. For a 5-year-old, a single year is a massive 20% of their entire life. It is an enormous, significant chunk of their existence. But for a 50-year-old, a year is just 2% of their life, a much smaller and less significant fraction. Each passing year is a smaller proportion of your total life story, so it naturally feels shorter and faster. It seems our perception of time is not a constant, but a shifting landscape, defined by the richness of our experiences and the ever-changing mathematics of our own age.
The elastic brain, how fear and joy bend time. While our age changes our perception of time over years, our emotions can radically stretch and compress it in a matter of seconds. Time, it turns out, is incredibly elastic, and our brain holds the strings. Think of a moment of sudden, intense fear. A car swerving into your lane, a sudden fall, or a loud, unexpected noise in a dark house. In these moments, many people report that time seems to slow down to a crawl. The world enters a state of slow motion, allowing you to perceive an incredible amount of detail. The pattern on the car's tire, the expression on a stranger's face, the texture of the ground as it rushes towards you. This isn't a superpower, but a fascinating trick of the brain's survival system. In a life-or-death situation, a part of your brain called the amygdala goes into overdrive. It commands the rest of your brain to start recording memories with the highest possible resolution, capturing far more information than it normally would. You aren't actually thinking or moving faster, but the memory you form of the event is so incredibly dense and detailed that when your brain plays it back for you moments later, it feels as though it must have lasted much longer than it actually did. It is a memory-based illusion that gives you the feeling of having had more time to react. Now, consider the opposite experience. Think of a time you were completely absorbed in something you love, a great conversation with a friend, playing a musical instrument, or getting lost in a creative project. In these moments, hours can feel like minutes. You look up at the clock, shocked to see how much time has vanished. This is often described as being in a flow state. When you are in this state, the part of your brain responsible for self-awareness and keeping track of time, the prefrontal cortex, becomes less active. You are so focused on the task at hand that you simply stop paying attention to the clock. Your sense of self melts away, and with it, your sense of time's passage. These two extremes prove that we don't have a single rigid internal clock. Instead, our perception of time is a fluid and dynamic experience, constantly being warped by our emotional state, proving that the timeline in our head is far more important than the one on the wall.
Chronesthesia, the brain's natural time machine. Take a moment and try something. First, think about what you ate for breakfast yesterday. Can you picture it? Can you almost taste it, remember where you were sitting and how you felt? Now think about your plans for this coming weekend. Can you imagine the places you might go, the people you might see, the things you might do? This seemingly simple act of remembering the past and planning for the future is, in fact, one of the most sophisticated and powerful abilities in the known universe. It is called chronesthesia, and it is our mind's own natural time machine. It's far more than just memory. Many animals have memory. A dog can remember where it buried a bone. But Chronesthesia is the conscious awareness of our own existence through time. It is the ability to mentally place ourselves in the past, the present, and the future, and to travel between these points at will. It is the foundation of what makes us human. This ability gives us a tremendous evolutionary advantage. It allows us to learn from our mistakes in a complex way, not just by avoiding a place of danger, but by replaying our actions in our mind and figuring out a better strategy for next time. It allows us to make plans, set long-term goals, and cooperate on a massive scale. It is the reason we can plant a seed in the spring with the full expectation of a harvest in the fall. Our brains have developed what can only be described as a virtual reality simulator. We can run endless simulations of future events, practicing a difficult conversation, visualizing success before a major event, or preparing for potential dangers. It's also the source of our deepest emotions, nostalgia for a past that is gone, and anxiety or hope for a future that has not yet arrived. It is the voice in our head that tells our life story. While our minds can effortlessly journey through our personal timelines, the physical universe is governed by much stricter rules. As we leave the internal world of the brain, we find that real physical time has its own bizarre laws that were completely invisible to us until one man changed everything. Time dilation, the universe's speed limit. For thousands of years, humanity viewed time as something absolute and universal. We believed there was a single cosmic master clock that ticked at the same rate for everyone and everything, everywhere in the universe. It was the one constant that could always be relied upon. Then, in the early 20th century, a young patent clerk named Albert Einstein completely shattered this idea. With his theory of special relativity, he revealed that time is not constant at all. It is relative, and its speed is directly linked to how fast you are moving. The core concept is known as time dilation, and it is as simple as it is profound. The faster you travel through space, the slower you travel through time relative to a stationary observer. Imagine you and a friend both have perfectly synchronized, ultra-precise clocks. Your friend stays on Earth while you board a spaceship and travel at a significant fraction of the speed of light. As you race through the cosmos, your clock will literally tick slower than your friend's clock back on Earth. This isn't a mechanical error or a trick of perception. It is a fundamental property of the fabric of reality called spacetime. This is not just a wild theory. It is a proven, measurable fact of our universe. Every day, we rely on a global network of satellites for GPS. These satellites are orbiting the Earth at very high speeds, thousands of miles per hour. Because of this speed, their internal clocks actually run slightly slower than our clocks on the ground. If the engineers did not constantly correct for time dilation, the tiny discrepancies would add up so quickly that the entire GPS system would become useless within a single day, leading to navigational errors of several miles. Einstein showed us that there is no universal now. Time is personal. Every moving object in the universe experiences time at its own unique rate. The effects are minuscule in our everyday lives, But as we approach the universe's ultimate speed limit, the speed of light, the consequences become truly mind-breaking.
The twin paradox, the ultimate trip. Time dilation is real, but what would it look like if we could push it to its most extreme limits? This question gives rise to one of the most famous thought experiments in all of physics, the twin paradox. It is a story that reveals the true consequences of Einstein's discovery and proves that time travel into the future is not only possible, but is a baked-in feature of our universe. The story begins with two identical twins. Let's call them a pair of astronauts, both aged 30. One twin, the Earth twin, decides to stay home. The other, the traveling twin, embarks on an incredible journey. She boards a state-of-the-art spaceship capable of traveling at 99.9% of the speed of light and sets a course for a star system that is 10 light-years away. From the perspective of the Earth twin, the journey is straightforward. Traveling at nearly the speed of light, the trip to the star will take just over 10 years, and the return trip will take another 10 years. When the spaceship lands back on Earth, a little over 20 years will have passed. The Earth twin will be 50 years old. But for the traveling twin, reality is completely different. Because she is moving so incredibly fast, her personal experience of time has slowed down dramatically. Her clocks, her heartbeat, her aging process, everything has been running in slow motion relative to Earth. For her, the entire 20-year round trip might have felt like only 2 years. When the traveling twin steps out of her spaceship, she is only 32 years old. She finds her sibling waiting for her, but he is now a 50-year-old man. She has aged only 2 years, while everyone and everything on Earth has aged 20. She has effectively leaped 18 years into the future. It's called a paradox because one might ask, from the traveler's perspective, wasn't the Earth moving away from her? The solution lies in the fact that the traveling twin had to accelerate, turn around, and decelerate, breaking the symmetry of their experiences. This isn't science fiction. It is the literal result of the laws of space-time. The twin paradox confirms that the future is not a place we must wait for. It is a destination we could, in theory, travel to.
Why time only moves forward. The law of entropy. We've just seen that time's speed can change, that it can be bent and stretched by speed and emotion. But through all of this, one thing remains stubbornly constant: its direction. Time always moves forward. You can remember the past, but you cannot remember the future. An egg can fall from a counter and shatter into a mess on the floor, but you will never see a mess of shattered pieces spontaneously leap up and reassemble into a perfect egg. We intuitively understand this forward flow. We call it the arrow of time. The puzzle, however, is that most of the fundamental laws of physics don't seem to care about this arrow. The laws of gravity, electromagnetism, and quantum mechanics are all time-symmetric, meaning they work perfectly well forwards or backwards. A video of a planet orbiting the sun would look just as physically plausible if you played it in reverse. So if the basic rules don't forbid it, why is our universe a one-way street? The answer, physicists believe,
lies in one of the most powerful and unavoidable laws in all of science, the second law of thermodynamics. This law introduces a concept called entropy, which is, in simple terms, a measure of disorder or randomness. The law states that in any isolated system, the total amount of entropy will always increase over time. The universe itself is the ultimate isolated system. It began in a state of incredibly low entropy, a hot, dense, highly ordered point at the Big Bang. Ever since that moment, it has been relentlessly moving toward states of greater and greater disorder. The shattered egg on the floor is a state of high entropy. Its molecules are in a chaotic, disordered arrangement. The whole egg is a state of low entropy. Its molecules are in a highly specific, ordered structure. There are vastly more ways for an egg to be broken than for it to be whole. This relentless march from order to disorder is what creates the arrow of time. Our experience of time flowing forward is simply our perception of the universe's unstoppable increase in entropy. It is the reason why stars burn out, why mountains erode, and why we age. The arrow of time is not a fundamental law in itself, but a consequence of the universe's starting conditions and its journey toward maximum chaos.
Can time run backward? The symmetry we never see. If the arrow of time is simply a consequence of increasing disorder, it begs a fascinating question. Could we reverse it? If the fundamental laws of physics are time-symmetric, why don't we ever see time flowing backward, even for a moment? Why don't broken things ever reassemble themselves? The answer is not that it's impossible, but that it is so outrageously, astronomically improbable that it might as well be. Think of it like a perfectly ordered rack of balls on a pool table. When you hit them with the cue ball, they scatter into a messy, disordered state. This is entropy increasing. Now, is it physically possible for you to hit that scattered, messy collection of balls in such a way that they all collide with perfect precision, lose their momentum, and fly back into a perfect, ordered triangle in the rack? According to the laws of motion, the answer is yes. It is technically possible. But the odds of it happening are so infinitesimally small that you could watch 1 billion pool tables for the entire age of the universe, and you would never, ever see it happen. The same principle applies to everything else. It's not that the universe forbids the molecules of a shattered egg from reassembling. It's that there are trillions upon trillions of disordered ways for those molecules to be, and only one highly specific ordered arrangement that makes a whole egg. The universe simply follows the path of highest probability, which is always the path toward more mess. Some physicists have even played with the speculative idea that there could be other regions of the universe, or perhaps even a twin anti-universe created alongside our own at the Big Bang, where the arrow of time runs in the opposite direction. In such a place, entropy would be decreasing, stars would be gathering gas from empty space, and beings would remember their future and be ignorant of their past. For us, however, locked in our cosmic neighborhood, the symmetry of time remains a beautiful theoretical idea that we will likely never see. The river of time is carved by the force of probability,
and that river only flows one way. Planck time, the smallest moment possible. We have talked about the speed of time and the direction of time. Now let's zoom in on its very texture. We experience time as a smooth, continuous, and unbroken flow. We can imagine dividing a second into a millisecond, then a microsecond, then a nanosecond, and we assume we could just keep dividing it forever into smaller and smaller slices. But according to our best understanding of physics, this is not the case. Time may not be a smooth river at all. It may, in fact, be a stream of individual, discrete droplets. This brings us to the concept of Planck time, which represents the smallest possible unit of time that can exist. It is a mind-bogglingly small number, roughly 10 to the power of negative 43 seconds. Writing it out would be a decimal point followed by 42 zeros and then a 1. To put that in perspective, there are more units of Planck time in a single second than there are seconds in the entire history of the universe since the Big Bang. This isn't just a randomly small number. It represents a fundamental limit where our current understanding of reality breaks down. It is the time it would take a particle of light, a photon, to travel the smallest possible distance, known as the Planck length. At scales smaller than this, the laws of gravity and quantum mechanics, which describe the very large and the very small, cease to make sense. At this level, the smooth fabric of spacetime is thought to dissolve into a chaotic, bubbling mess known as quantum foam. In this foam, our familiar concepts of before and after may lose all meaning. This suggests that our experience of time as a continuous flow is an illusion created by our macroscopic scale. Just as a movie appears to be in smooth motion, but is actually made of thousands of individual static frames, our entire reality might be unfolding frame by frame, with each frame lasting for 1 unit of Planck time. It is the ultimate tick of the universe's clock, a fundamental rhythm beneath everything, suggesting that time itself is not infinitely smooth, but grainy. Einstein's spacetime, time as a dimension. Our journey so far has treated time as a mysterious current that carries us forward. But Albert Einstein's greatest revolution was to propose something even more profound. Time is not a current, but a place. It is a dimension. For most of human history, we thought of the universe as having 3 dimensions of space: length, width, and height. Time was seen as something separate, a universal clock that ticked away in the background, the same for everyone. Einstein's theories of relativity fused these 2 concepts together. He showed that space and time are inextricably linked into a single 4-dimensional fabric called spacetime. The easiest way to understand this is to think about how you would arrange a meeting with a friend. You need to provide 3 pieces of information to specify the location: a street address, or length, a cross street, or width, and which floor of the building to meet on, or height. But without one more crucial piece of information, the meeting will never happen. You need to specify when to meet. That when is the 4th dimension, time. An event in our universe is not just a point in space, but a point in space-time. This wasn't just a clever new way of labeling things. It changed our understanding of the universe's most powerful force, gravity. Einstein realized that gravity is not a mysterious force pulling objects toward each other. Gravity is the shape of spacetime itself. A massive object, like the sun, bends and warps the four-dimensional fabric of spacetime around it, like a heavy bowling ball placed on a trampoline. A smaller object, like the Earth, trying to travel in a straight line through this curved spacetime, is guided along a curved path, which we perceive as an orbit. This is also why moving fast through space affects your experience of time, as we saw with the twin paradox. In this model, every object is traveling through spacetime. The more of your motion you dedicate to moving through the three spatial dimensions, the less you have available to move through the time dimension. This unified vision transformed time from an abstract concept into a physical, tangible part of the universe's structure, a dimension as real as any of the three we can see and touch. The block universe. Is the future already written? If we accept Einstein's idea that time is a fourth dimension, just like the three dimensions of space, we are led to a startling and deeply unsettling conclusion about the nature of our reality. This conclusion is known as the block universe theory, or Eternalism. Think about space. The city of Paris is not happening right now more than the city of Tokyo. Your childhood home isn't less real than where you live now. All places in space exist simultaneously. Your location simply determines which one you are currently experiencing. The block universe theory suggests that we should think about time in the exact same way. If time is a dimension, then the past, the present, and the future all exist together, simultaneously. The entire history of the universe, from the searing heat of the Big Bang to the cold darkness of its final end, could be viewed as a single, unchanging, four-dimensional block of space-time. In this view, the dinosaurs are not gone. They are just located at a different point in the time dimension. The distant future, with its unknowable civilizations and dying stars, is not something that is yet to be created. It is already there, at a different time coordinate. Our powerful feeling that the present moment, the now, is special and real is nothing more than an illusion of our consciousness. Our awareness is like a spotlight moving along this pre-existing timeline. The spotlight illuminates one moment, and we call it the present. The moments it has just passed, we call the past, and the moments it has yet to reach, we call the future. But the parts of the timeline that are not in the spotlight are just as real. This, of course, has profound implications for the idea of free will. If the future already exists in its entirety, does that mean all of our choices have already been made? Are we truly making decisions that shape our destiny? Or are we simply playing out a role in a cosmic movie that has already been filmed from beginning to end? The block universe suggests that our journey through life is not one of creation, but one of discovery, as our consciousness simply reveals a future that was always there, waiting for us.
The Big Bang, the beginning of time. For millennia, humanity has looked up at the stars and asked the ultimate question: how did this all begin? For the longest time, we imagined a static, eternal universe that had always existed. But in the 20th century, a revolutionary story began to unfold,
a story that gave our universe a birthday. This is the story of the Big Bang. About 13.8 billion years ago, everything we can see, every star, every galaxy, every planet, every atom in your body was compressed into a single point of infinite density and unimaginable heat. This point, known as a singularity, contained all the space, all the matter, and all the energy of our entire universe. It's crucial to understand that this was not an explosion in space, like a bomb going off in an empty room. It was an explosion of space itself. There was no outside to the singularity, no empty void for it to expand into. In that first singular moment, space itself began to expand, carrying all the matter and energy with it, like raisins in an expanding loaf of bread. But the Big Bang was not just the beginning of space and matter. It was the beginning of time itself. The question, what came before the Big Bang, might be a meaningless one. It's like asking, what is north of the North Pole? Since time itself began at that moment, there was no before. At time equals zero, the laws of physics as we know them break down. This is the moment the cosmic clock started ticking. From this initial, incredibly hot and simple state, the universe began to cool and expand. Energy congealed into the first particles, which eventually formed atoms. These atoms were pulled together by gravity to form the first stars and galaxies. The evidence for this incredible origin story is all around us. We can observe that distant galaxies are all rushing away from us, proof of this ongoing expansion. And we can still detect the faint, leftover heat from that initial fireball, a cosmic microwave background radiation that fills all of space like a faint, lingering echo of creation. The Big Bang Theory gives us a definitive starting point, transforming time from an abstract, infinite line into a finite story with a clear beginning.
The Big Crunch and Big Bounce, an endless cosmic breath. If the universe had a definitive beginning, it's only natural to ask, will it have an end? For much of the 20th century, one of the leading theories for the ultimate fate of the cosmos was a beautifully symmetric idea known as the Big Crunch. This theory proposed that the story of the universe might be a round trip. It all depends on one critical factor: just how much stuff is in the universe. If the total mass and energy of the universe were great enough, then the force of gravity, pulling everything back together, would eventually overcome the outward momentum of the Big Bang's expansion. In this scenario, the expansion of the universe would gradually slow down over countless billions of years. It would eventually come to a complete halt, and then, slowly at first, and then with gathering speed, it would reverse. A great contraction would begin. Distant galaxies would stop receding and would start hurtling toward us, their light shifting from red to blue. The universe would grow smaller, hotter, and denser. Eventually, all the galaxies would merge, stars would be ripped apart, and all matter and energy would collapse back into a single, infinitely hot and dense singularity, just like the one from which it all began, the Big Crunch. But what would happen then?
Would that be the final, ultimate end? This is where the idea gets even more fascinating, evolving into the Big Bounce theory. Some physicists have proposed that the collapse into a singularity would be so violent that it would trigger a rebound, igniting another Big Bang and creating a brand new universe from the ashes of the old one. In this breathtaking vision, time is not a finite line with a beginning and an end. Instead, it is an eternal cosmic cycle. Our universe could just be one in an infinite series of universes, each one born from the death of the one before it, like a cosmic phoenix. It's a vision of the universe taking an endless cosmic breath, exhaling for eons in a Big Bang and inhaling for eons in a big crunch. While current evidence suggests our universe's expansion is actually accelerating, not slowing down, the Big Bounce remains a powerful and poetic possibility for the ultimate nature of cosmic time.
Heat death of the universe, when the clock finally stops. The vision of a cyclical, bouncing universe is a comforting one, but it is not what our current observations of the cosmos are telling us. In the late 1990s, astronomers discovered something shocking. The expansion of the universe is not slowing down due to gravity, it is speeding up. There appears to be a mysterious, invisible force at work, pushing everything apart. We call this force dark energy, and it seems to hold the key to the universe's true, final destiny. If this accelerated expansion continues, the universe is headed for a future known as the heat death, or the Big Freeze. It is a slow, quiet, and profoundly lonely end. The story unfolds over unimaginable timescales. First, over billions of years, the accelerating expansion will push all galaxies that are not gravitationally bound to our own, so far away that their light will never be able to reach us. They will vanish beyond our cosmic horizon, leaving our own local group of galaxies as an isolated island in an endless, empty void. Then, the internal clock of this island universe will begin to wind down. Over trillions of years, the fuel for star formation will run out. The last stars will be born, shine, and then die, one by one. The universe will grow darker and colder, populated only by the fading embers of stellar remnants, like black holes, neutron stars, and cold white dwarfs. But even this is not the end. Over timescales so vast they defy human comprehension. Trillions upon trillions of years, even these remnants will decay. Protons themselves may dissolve, and black holes are predicted to slowly evaporate into a faint fizz of radiation. Ultimately, the universe will approach a final, permanent state. It will be a vast, dark, and featureless soup of stray particles and low-level radiation, with everything at a uniform, near absolute zero temperature. This is the state of maximum entropy, or perfect disorder. In a universe where there are no temperature differences, no energy can flow, and nothing can happen. All processes will cease. In such a universe, where there is no change, does time itself still have any meaning? The arrow of time, driven by the universe's march towards disorder, will have reached its destination. The cosmic clock will not just stop. The very concept of a clock ticking will become irrelevant in the final, cold, and eternal silence.
The holographic principle. Are we living on a flat surface? We have been exploring the vast three-dimensional universe and its timeline.
But what if that is all an illusion? What if the reality we experience is a complex projection, like a hologram? This is the core idea behind one of the most bizarre and mind-bending concepts in modern physics, the holographic principle. The idea emerged not from cosmology, but from the study of black holes. Physicists were puzzled by what happens to information, the unique arrangement and properties of matter when it falls into a black hole. According to quantum mechanics, information can never be truly destroyed, but a black hole seems to erase it from our universe. In trying to solve this puzzle, scientists like Gerard 't Hooft and Leonard Susskind discovered a remarkable mathematical property. They found that the total amount of information that could ever be contained within a certain volume of space is not proportional to the volume itself, which is what you would expect. Instead, it is proportional to the surface area of that region. This is a shocking result. It's like discovering that the amount of data you can store on a hard drive depends not on the size of the drive itself, but on the surface area of its outer casing. This suggests that the information that describes all the three-dimensional stuff inside a region of space can actually be fully encoded on its two-dimensional boundary. Now let's scale this idea up to the entire universe. The holographic principle proposes that our entire three-dimensional reality, including you, me, the Earth, and the distant galaxies, might be nothing more than a complex holographic projection of information that is stored on a distant two-dimensional surface at the very edge of the cosmos. In this view, the real universe is a flat, alien landscape of information, and what we perceive as depth, distance, and the passage of time are all emergent properties of this projection. Time, as we experience it, this dynamic flowing sequence of events, might be like the frame rate of the hologram, the process by which the 2D information is rendered into the 3D world we know. This theory fundamentally challenges our sense of what is real, suggesting that we may be the ghosts in the machine, intricate projections from a reality far flatter and stranger than we could ever imagine.
Simulation hypothesis. Is time just a line of code? If our universe is like a hologram, with all of reality encoded as information, it leads to an even more unsettling possibility. What if that information is being run on a computer? This is the simulation hypothesis, a modern take on an ancient philosophical question. How do we know that our reality is real? The argument, brought into the mainstream by philosopher Nick Bostrom, is based on a simple line of probability. First, you assume that it is possible for a civilization to become technologically advanced enough to create a simulated reality that is indistinguishable from the real thing, populated by conscious, simulated beings. Think of an incredibly advanced video game. Second, you assume that such a civilization would likely run many, many such simulations, perhaps for scientific research, for entertainment, or for reasons we can't even fathom. If these two assumptions are true, then the sheer number of simulated realities would vastly outnumber the one, single, base reality. Therefore, based on pure statistics, it is overwhelmingly more probable that we are living inside one of those countless simulations than that we are the original, organic beings in the one true universe. This idea reframes the entire cosmos in a new light. The elegant laws of physics, like gravity and electromagnetism, would be the code of the simulation. The speed of light, the universe's ultimate speed limit, might be the processing speed limit of the cosmic computer running our world. Planck time, the smallest possible unit of time, could be the computer's clock cycle, the refresh rate of our reality. And what about time itself? In a simulation, time would not be a fundamental dimension of the universe, but simply a programmed variable. The arrow of time would be nothing more than the program running forward, from line 1 of the code to the end. It could imply that time could be paused, rewound, or even edited by the simulators outside our reality. The glitches we sometimes perceive, like déjà vu, could be literal bugs in the software. This hypothesis is perhaps the ultimate mystery, transforming time from a cosmic force into a simple line of code, and our entire universe into a grand, elaborate, and perhaps fragile illusion. Quantum foam. The chaos at reality's edge. We experience the world as a stable and predictable place. The ground beneath our feet is solid, and the flow of time feels smooth and orderly. But if we could zoom in, way down to the smallest possible scales of reality, we would discover a universe that is anything but calm. Down at the level of the Planck length and Planck time, the very fabric of space-time is thought to dissolve into a seething, chaotic, and violent maelstrom. This is the world of quantum foam, a concept first proposed by the brilliant physicist John Wheeler. He theorized that at this incredibly tiny scale, the principles of quantum mechanics, which govern the bizarre behavior of particles, would take complete control over space-time itself. The smooth, gently curving geometry described by Einstein would no longer apply. Instead, space-time would be constantly churning. Tiny, virtual particles would be popping into and out of existence in an endless dance of creation and annihilation. Tiny wormholes and microscopic bubbles of space-time might be forming and vanishing in less than a second. In this chaotic foam, our familiar understanding of before and after would completely break down. Cause and effect would become a meaningless jumble. Time, as a coherent forward-moving arrow, would not exist. It would be a bubbling, probabilistic chaos where the past, present, and future are all mixed together in a turbulent sea of possibilities. So why don't we feel this chaos? Because, on our large macroscopic scale, all of these tiny, violent fluctuations average out, creating the illusion of a smooth and stable reality. Just as the chaotic motion of trillions of individual water molecules averages out to create the smooth surface of a calm lake. This idea suggests that the orderly, predictable flow of time that governs our lives is not a fundamental property of the universe. Instead, it is an emergent phenomenon, a statistical average that arises from a much deeper, more violent, and utterly chaotic reality.
The steady ticking of the clock we perceive is just the calm surface of a raging quantum storm, where the very concept of time is being constantly born and destroyed.
Is time an illusion? The theory of emergence. We've seen hints of this idea throughout our journey. Time feels different depending on our age and emotions. It slows down at high speeds. It may not even exist at the smallest scales. This leads to one of the most profound and debated questions in all of physics. Is time a fundamental ingredient of the universe, or is it an illusion? The theory of emergence suggests it is the latter. In this view, time is not a core piece of the universal machine, but rather a secondary effect that emerges from a deeper, timeless reality. Much like a traffic jam emerges from the interactions of individual cars. No single car is the traffic jam, but their collective behavior creates it. Similarly, our experience of time might emerge from the quantum interactions of all the particles in the universe. A leading version of this idea comes from attempts to unite Einstein's theory of gravity with quantum mechanics. In some of these theories, the most fundamental equations that describe the universe have no time variable in them at all. At the deepest level of reality, things don't happen in a sequence. There is just a static, timeless is. So where does our powerful sense of a flowing now come from? It could be a product of quantum entanglement. One part of the universe, let's call it our brain, becomes entangled with another part of the universe, let's call it a clock. The change and correlation between these entangled states is what we then perceive and interpret as the passage of time. Time, in this sense, is a relationship, not a thing in itself. It is a feature of our macroscopic, complex world, but not of the simple, underlying reality. It's like temperature. A single atom doesn't have a temperature. Temperature is an emergent property of the average motion of many atoms. In the same way, time might be an emergent property of the quantum relationships between objects in the universe. This would mean that the most fundamental question is not what is time, but why do we perceive time? The answer might be that our consciousness itself constructs the illusion of flow from a universe that is, at its core, eternally frozen. Time symmetry and the broken laws of physics. One of the most powerful tools physicists use to understand the universe is the search for symmetry. A perfect sphere is symmetric because it looks the same no matter how you rotate it. The laws of physics were long believed to have a set of fundamental symmetries, one of the most important being time symmetry, or T-symmetry. As we've discussed, this means that the laws should work the same forwards in time as they do backwards. For decades, this was a core assumption. But in 1964, a groundbreaking experiment studying the decay of strange particles called kaons revealed a shocking truth. The universe has a flaw. It was discovered that a tiny fraction of these particles behave differently forwards in time than they do backwards. The symmetry was broken. This was a monumental discovery. It was the first time a fundamental law of physics was shown to have a built-in preference for a direction in time. It's a very, very subtle effect, seen only in the bizarre world of subatomic particles, but its implications are enormous.
It means that the universe, at its most basic level, can tell the difference between the past and the future. This T-violation might be a crucial piece of an even bigger puzzle, the mystery of why our universe is made of matter and not antimatter. The Big Bang should have created equal amounts of matter and its oppositely charged twin, antimatter. When matter and antimatter meet, they annihilate each other in a flash of energy. So the universe should be an empty void filled with light. The fact that we are here, made of matter, means that something tipped the scales in the very first moments of creation, creating slightly more matter than antimatter. Physicists now believe that this tiny crack in time symmetry, this subtle preference for one direction, might be the very reason our universe exists at all. It suggests that the arrow of time is not just a statistical trend of increasing disorder, but is also etched, however faintly, into the most fundamental laws of nature, a broken symmetry that allowed for a universe of something instead of nothing.
Time without motion, a frozen universe. We instinctively link the passage of time with motion and change. We see the hands of a clock moving, the sun arcing across the sky, our own bodies aging. We think to ourselves, if everything in the universe were to stop, completely frozen in place, would time still be passing? The philosopher and physicist Julian Barbour has championed a radical and thought-provoking idea that challenges this very connection. He argues that motion is not the consequence of time, but that time is the consequence of motion. In his view, the universe does not consist of objects moving through time. Instead, it consists of a series of an infinite number of distinct, static, and timeless nows. Each now is a complete and self-contained arrangement of all the matter in the universe, like a single frozen photograph. Imagine a movie film strip. Each frame on that strip is a static image. When you run the film strip through a projector, you create the illusion of motion and the passage of time. Barbour suggests that the universe is like that film strip, a vast collection of all possible static frames, all existing simultaneously. What we perceive as the flow of time and the arrow of time is simply our consciousness moving from one of these frames to the next in a sequence that creates a coherent and consistent story. We move from a frame showing an egg on a counter to a frame showing it halfway to the floor, to a frame showing it shattered on the ground. We interpret this sequence as an egg falling over time, but in this view, all three nows, the whole egg, the falling egg, and the broken egg, are equally real and exist eternally. This vision of a frozen universe, where change is an illusion created by our journey through a landscape of static moments, is one of the most profound challenges to our everyday experience. It suggests that nothing ever truly moves or changes. Instead, reality is a vast collection of snapshots, and what we call time is simply the path our awareness takes as it threads its way through the cosmic photo album.
Schrödinger's cat, time, probability, and parallel worlds. One of the most famous and misunderstood thought experiments in all of science is the story of Schrödinger's cat.
It was designed by physicist Erwin Schrödinger to show the absurd consequences of applying the rules of the quantum world to our everyday macroscopic world. The setup is this. A cat is placed in a sealed box. Inside the box is a vial of poison, a hammer, and a radioactive atom. If the atom decays, it triggers the hammer, which smashes the vial, and the cat perishes. The crucial point is that the decay of the radioactive atom is a purely quantum event governed by probability. According to quantum mechanics, until we observe the atom, it is not in one definite state. It exists in a superposition of both states at once. It has both decayed and not decayed. Therefore, if the cat is linked to this quantum system, the cat itself must also be in a superposition. Until we open the box and look, the cat is simultaneously both alive and dead. This seems absurd, but it highlights a central mystery. How and when does this blurry world of quantum probabilities collapse into the single definite reality we experience? This has a profound connection to time. It suggests that the future is not a single predetermined path, but a branching tree of possibilities. Every quantum event is a fork in the road. When the atom is in superposition, two potential futures exist, one where the cat lives and one where it dies. The many worlds interpretation, which we touched on earlier, takes this idea to its logical conclusion. It suggests that reality doesn't collapse into one outcome. Instead, at the moment of the quantum event, the universe itself splits in two. In one universe, the atom doesn't decay, and an observer opens the box to find a living cat. In the other, the atom does decay, and an observer opens the box to find a dead cat. This process would be happening constantly, with every quantum flicker, creating an infinite number of parallel timelines. In this view, time is not a single line, but an endlessly branching tree, with every possible future being played out in its own separate reality.
Augustine's puzzle. If no one asks me, I know. Long before Einstein theorized about spacetime and physicists debated the Big Bang, a Christian theologian and philosopher named Augustine of Hippo grappled with the nature of time in a way that is still profoundly relevant today. In his famous book, Confessions, written around the year 400 AD, he penned one of the most elegant and frustrating summaries of the temporal mystery ever written. He famously asked, "What then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not." This single sentence perfectly captures the paradox of our relationship with time. We live in it, we feel it, we measure it, and we organize our entire lives around it. The concept is so deeply embedded in our consciousness that we feel we understand it intuitively. Yet the moment we try to define it, to pin it down with words and logic, it slips through our fingers like sand. Augustine went on to explore this puzzle with incredible insight. He questioned how we can even speak of the past and future. The past, he argued, is no longer real because it has already gone. The future is not yet real because it has not yet arrived. That leaves only the present moment, the now.
but even this present moment is fleeting. If it has any duration, any length, then it must be divisible into a past part and a future part, which means it isn't truly the present. He concluded that the present must be an infinitesimal knife-edge point with no duration at all. So how can we measure time? Augustine's revolutionary idea was to suggest that time is not a property of the external world, but a property of the mind itself. He proposed that the past exists only as a memory in our minds, and the future exists only as an anticipation, also in our minds. Time for Augustine was a stretching of the soul, a subjective psychological experience. This was a radical departure from the idea of a universal external clock. He had, in essence, discovered the psychological arrow of time more than 1,500 years before modern neuroscience. His ancient puzzle remains unsolved, reminding us that even with all our scientific progress, the simple act of defining the most fundamental aspect of our existence is as challenging now as it was for a Roman philosopher in the twilight of his empire.
Presentism versus Eternalism. Does only the present exist? Augustine's puzzle leads directly to one of the central debates in the philosophy of time, a clash of two completely different ways of viewing reality: presentism and eternalism. Presentism is the theory that feels most intuitive to us. It is the belief that only the present moment is real. In this view, the past is gone, a collection of events that once existed but no longer do. The future is a realm of pure potential, a collection of possibilities that have not yet come into being. Reality is a single moving spotlight, and only what is illuminated by that spotlight, the now, truly exists. The dinosaurs are not real. The future colonies on Mars are not real. Only this very moment, as you are experiencing it, is real. This aligns with our deep-seated feeling of a flowing, dynamic time, where the future is open and our choices genuinely create what is to come. However, this view has some serious problems, especially when confronted with modern physics. As we've learned from Einstein, there is no universal now. Two observers moving at different speeds will have different definitions of what is happening at the same time. This makes the idea of a single universal present moment very difficult to defend. The alternative view is eternalism, also known as the block universe theory, which we've touched upon. This is the idea that the past, present, and future are all equally real. Just as all places in space exist, all moments in time exist. The dinosaurs are not gone. They are just located at a different coordinate in space-time. Your future self is just as real as your present self. In this view, time does not flow. It is a static, unchanging landscape, and our consciousness simply experiences it sequentially. This view is far more compatible with the physics of relativity, but it comes at a huge philosophical cost. It seems to imply that the future is already written, and that our sense of free will is a profound illusion. This ancient debate forces us to make a choice. Is reality a single, fleeting moment of becoming, where the future is unwritten? Or is reality a vast, eternal block of being, where all of history is laid out and our journey is one of discovery, not creation? Your answer defines your entire relationship with the universe. Nietzsche's eternal recurrence. Would you live this life again? What if you were forced to live your life over and over again, in exact detail, for all of eternity? Not a similar life, but this exact one, with every joy, every heartache, every mistake, and every moment of boredom. Would this be a horrifying curse or the ultimate blessing? This is the core of one of the most powerful and terrifying thought experiments in all of philosophy, the eternal recurrence, proposed by the German philosopher Friedrich Nietzsche. He presented it not as a theory of how the universe actually works, but as a test of one's own life. Imagine a demon creeping into your loneliest loneliness and saying to you, "This life, as you now live it and have lived it, you will have to live once more, and innumerable times more. The eternal hourglass of existence is turned upside down again and again, and you with it, speck of dust." Nietzsche asks how you would react. Would you throw yourself down, gnash your teeth, and curse the demon? Or would you have a moment of divine clarity and tell the demon, "You are a god, and never have I heard anything more divine"? The idea is a brutal and brilliant tool for self-reflection. It forces you to confront the value of your own existence in a profound way. Are you living a life that you would be willing to repeat, with all its suffering, for the sake of its beautiful moments? It is the ultimate affirmation of life, a concept he called amor fati, or love of one's fate. To embrace eternal recurrence is to love your life so completely that you would want nothing to be different, because to change a single painful detail would be to risk changing the entire tapestry. This idea also radically transforms our perception of time. It fuses the past and future into a single momentous present. Every decision you make is no longer just for this one life. It is for an infinity of lives. The weight of every moment becomes infinite. It is a call to live with such purpose and passion that the thought of an eternal repetition would not be a source of despair, but the greatest possible joy.
Hindu cycles of time, the cosmic ocean of Yugas. While Western philosophy often grapples with linear or repeating individual lives, ancient Hindu cosmology offers a vision of time that is both vast and cyclical on a cosmic scale. This is the concept of the Yugas, or ages. In this worldview, time is not a straight line moving from a single creation to a single end. Instead, it is an immense, repeating cycle, like the turning of a great cosmic wheel. The full cycle is called a Mahayuga, or Great Age, and it lasts for an incredible 4.32 million years. This Mahayuga is itself divided into 4 smaller, distinct ages, or yugas, each with its own character. The first is the Satya Yuga, a golden age of truth, virtue, and enlightenment that lasts for 1.728 million years. In this era, humanity is said to be gigantic, powerful, and deeply connected to the divine. Following this is the Treta Yuga, a silver age where virtue begins to decline. This age lasts for 1.296 million years. Next comes the Dwapara Yuga,
a Bronze Age of further decline and conflict, lasting 864,000 years. Finally, we arrive at the age we are currently said to be in, the Kali Yuga, the Iron Age of darkness, conflict, and spiritual ignorance. It is the shortest and most degraded of the ages, lasting 432,000 years. At the end of the Kali Yuga, the world is said to descend into such chaos and decay that the universe is dissolved in a process called prolaya. But this is not a final end. After a period of cosmic rest, the universe is recreated and the entire cycle of yugas begins anew, with a fresh, golden age. This vision of time is profoundly different from the linear, one-shot narrative common in the West. It suggests that creation and destruction are not unique events, but are part of an eternal, rhythmic cosmic breath. It imbues time with a sense of immense scale, making a single human lifespan seem like a tiny ripple in a vast, cyclical ocean of existence.
Mayan calendars, the end of a world, not the world. In 2012, a wave of panic and fascination swept the globe, centered on a single idea. The Mayan calendar was about to end, and with it, the world. This was, of course, a profound misunderstanding of one of the most sophisticated and complex timekeeping systems ever developed. The Maya did not have one single calendar, but a series of interlocking calendars, each measuring different cycles of time. Their most famous one is the long count calendar. Unlike the cyclical calendars common in many cultures, the long count was a grand linear count of days, starting from a mythical creation date, which corresponds to August 11th, 3114 BC in our system. The calendar was structured in cycles. The largest of these cycles was the Baktun, a period of 144,000 days, or roughly 394 years. The date that caused so much alarm, December 21, 2012, corresponded to the completion of the 13th Baktun. For the ancient Maya, the number 13 was sacred and significant. The completion of the 13th Baktun was not an apocalypse, but the end of a major world age, a moment of profound transformation and renewal, much like our own celebration of a new year or a new millennium, but on a far grander scale. It was the end of a great creative cycle, which would then be followed by the beginning of the next. Their worldview was not one of a final fiery end, but of endless cycles of creation, destruction, and rebirth. Their incredibly precise astronomical observations allowed them to measure not just the cycles of the sun and moon, but also the vastly longer cycles of planets like Venus and even the slow wobble of the Earth's axis. For the Maya, time was not just a way to track the days. It was a sacred, living entity, a series of interwoven cosmic rhythms. To understand these rhythms was to understand the will of the gods and the very structure of the universe. Their calendar was not a doomsday clock, but a map of eternity, charting the endless dance of creation.
Buddhism and the illusion of a continuous self.
While many philosophies see time as the river in which we live, Buddhism offers a more radical perspective. Time, and our sense of a continuous self that moves through it, are both powerful illusions. At the core of Buddhist thought is the concept of anicca, or impermanence. This is the understanding that everything in the universe, from a distant star to a fleeting thought, is in a constant state of flux. Nothing is permanent. Nothing is fixed. This applies not just to the world around us, but to our own consciousness. Buddhism teaches that there is no solid, unchanging self or soul that journeys through life. What we perceive as our self is actually a dynamic and ever-changing process, a collection of 5 aggregates: our physical body, our feelings, our perceptions, our mental formations, and our consciousness. These components are constantly arising and passing away, moment by moment. The illusion of a continuous self is created by the rapid succession of these moments, much like the individual static frames of a movie create the illusion of a continuous, moving picture. This leads to a profound reinterpretation of time. If there is no permanent self, then who is it that experiences the past, present, and future? In the Buddhist view, the past is nothing more than a memory appearing in the present moment. The future is nothing more than a thought or projection, also appearing in the present moment. The only thing that is ever truly real is the present moment itself, a concept known as momentariness. Reality is a series of discrete, fleeting moments, each one born from the conditions of the last and giving rise to the conditions of the next, but with no persistent entity traveling between them. To truly understand this is to be liberated from the primary sources of human suffering: regret and attachment to a past that is gone, and anxiety and craving for a future that does not exist. By dissolving the illusion of a solid self traveling through a solid timeline, Buddhism encourages a focus on the profound depth and potential of the only thing we ever truly have: the immediate, ever-changing now. Zeno's paradox, the impossible race you can never finish. Over 2,400 years ago, the Greek philosopher Zeno of Elea devised a series of brilliant and frustrating puzzles that have challenged mathematicians and thinkers ever since. His most famous paradox, Achilles and the tortoise, strikes at the very heart of our understanding of time, space, and motion. The scenario is simple. The swift warrior Achilles is to race against a slow tortoise. Being a good sport, Achilles gives the tortoise a head start. The race begins. In the time it takes Achilles to run to the tortoise's starting point, the tortoise has, of course, moved a little bit further ahead. Now Achilles must run to this new point. But in the time it takes him to do that, the tortoise has crawled forward yet again, a smaller distance, but a distance nonetheless. This process continues. Every time Achilles reaches the spot where the tortoise just was, the tortoise will have moved a tiny bit further on. Logically, it seems Achilles can never actually overtake the tortoise, because he must first cover an infinite number of smaller and smaller distances. Another of Zeno's paradoxes, the dichotomy paradox, argues that to walk across a room, you must first walk halfway across. To cover that remaining distance, you must first cover half of it, and so on, forever. Since there is an infinite number of halfway points you must cross, you can never logically even begin your journey. These paradoxes were not meant to prove that motion is actually impossible. We see things move all the time. Instead, they were designed to show that our common-sense understanding of space and time as being infinitely divisible leads to logical absurdities. For centuries, these puzzles were treated as philosophical novelties, but they hinted at a deep truth. The modern mathematical concept of a limit and the development of calculus eventually provided a formal way to show that an infinite series of numbers can indeed add up to a finite sum. However, the paradoxes have taken on new life in the quantum age. Ideas like Planck time and Planck length suggest that space and time may not be infinitely divisible after all. Zeno's ancient puzzles, in their elegant simplicity, forced us to confront the possibility that the smooth, continuous reality we perceive might be an illusion built upon a grainy, quantized foundation.
Time in Islamic philosophy, created time versus divine time. During the Islamic Golden Age, from the 8th to the 13th centuries, brilliant thinkers in cities like Baghdad and Córdoba engaged in profound debates about the nature of God, reality, and time. Their work, which preserved and expanded upon ancient Greek philosophy, led to sophisticated and nuanced views of existence. A central concept in much of Islamic philosophy is the distinction between two fundamentally different types of time: created time, zaman, and divine or eternal time, dar. Created time, or zaman, is the familiar, sequential time that we experience in the physical world. It is the time of before and after, of cause and effect, of change and decay. Philosophers like Al-Kindi and Avicenna saw this form of time as being intrinsically linked to the motion of celestial bodies and the processes of the created universe. It had a beginning, and it is a feature of the contingent physical world. However, this was seen to be just one layer of reality. Beyond this created sequential time, they posited the existence of dar, which can be thought of as a state of timeless eternity. This is the time of God. Dar is not an infinitely long duration, but a state of being in which the past, present, and future are all co-present in a single eternal now. For God, in this view, there is no sequence of events. All of history is perceived at once. This elegant distinction allowed philosophers to resolve complex theological problems. For example, how can God have perfect knowledge of the future if humans have free will? The answer lies in the two types of time. From our perspective, within created time, zaman, the future is open and our choices are real. But from God's perspective, outside of created time, in the eternal state of dar, our future choices are simply part of the complete tapestry of reality that He perceives simultaneously. This worldview presents a multi-layered reality, where our linear, flowing experience of time is a genuine feature of our created existence, but it is encompassed by a vaster, timeless, divine reality, where all of history exists in a single, unchanging moment. Time in Christian theology,
from Genesis to Revelation. The concept of time within mainstream Christian theology is profoundly linear and narrative-driven. Unlike the cyclical views of Hinduism or the static nows of a philosopher like Barber, the Judeo-Christian timeline is a story with a definitive beginning, a dramatic middle, and a final purposeful end. This framework shapes the entire understanding of human existence and its meaning. The story begins in Genesis with the act of creation. Time itself is a created thing, brought into being by God's will. In the beginning marks the start of the cosmic clock and the unfolding of history. The timeline then proceeds through a series of key events: the fall of man, the covenant with Abraham, the exodus from Egypt, and the coming of the prophets. Each event is a step in a divine plan, a purposeful progression. The absolute center of this timeline is the life, death, and resurrection of Jesus Christ. This is the pivotal moment, the turning point of all history, which divides time itself into before Christ, BC, and Anno Domini, the year of our Lord. This event is seen as the ultimate intervention of the eternal into the temporal, a moment when God stepped into the flow of human history. The story then continues with the age of the Church, leading towards a prophesied and definitive conclusion. The end of time, as described in books like Revelation, is not a simple fading away, but a dramatic climax, the second coming of Christ, the final judgment, and the creation of a new heaven and a new earth. In this new reality, time as we know it, a sequence of change, decay, and death, will be no more, replaced by an eternal state of being with God. This linear, goal-oriented view of time imbues history with a profound sense of meaning and purpose. Every moment is significant because it is part of a grand divine narrative that is moving towards a final resolution. It is a story of fall and redemption, where time is the stage upon which the ultimate drama of salvation is played out. Ancient Greek paradoxes of infinity. The ancient Greeks, with their love of logic and reason, were the first to truly wrestle with the mind-bending concept of infinity, and their struggles revealed deep paradoxes about the nature of time. Zeno's paradoxes of motion were just the beginning. Other thinkers explored different facets of the infinite that directly challenge how we think about the past and future. One such puzzle is the impossible past paradox. It argues that the past cannot be infinitely long. The reasoning is as follows. If the past were infinite, then an infinite number of days must have passed to get to today. But it is impossible to complete an infinite series of events, one after another. To get to the present, the universe would have had to cross an infinity, which is a logical contradiction. Therefore, the paradox concludes, the past must be finite, and the universe must have had a beginning. This ancient logical argument remarkably prefigures the modern cosmological theory of the Big Bang. Another puzzle, sometimes called Tristram Shandy's paradox, explores the future. It imagines a character who is writing his autobiography, but he is so meticulous that it takes him a full year to write about a single day of his life. The question is, can he ever finish his story?
As he lives, he creates more material to write about than he can possibly document. His task is endless. His story's end gets further and further away the longer he writes. This illustrates how certain processes, once started, can generate an infinite future, never reaching a conclusion. These paradoxes were more than just clever brain teasers. They were the first serious attempts to apply rigorous logic to the structure of time. They forced a distinction between a potential infinity, a process that can be continued forever, like counting, and an actual infinity, a completed, existing infinite set. The Greek struggles with these ideas laid the intellectual groundwork for centuries of debate in mathematics, philosophy, and theology, demonstrating that even before the invention of telescopes or atomic clocks, the human mind could probe the deepest and most confounding mysteries of eternity. Time and free will. Are we puppets of causality? We have arrived at one of the most personal and consequential mysteries in our entire exploration. It is the question of whether we are the authors of our own lives or simply actors reading from a pre-written script. This is the ancient and unresolved conflict between free will and determinism, and time is the battlefield on which it is fought. The argument for determinism is simple and powerful. It begins with the idea of causality. Every event is caused by a preceding event. If you trace this chain of cause and effect backward, you can see that the state of the universe one moment ago completely determines the state of the universe right now. If you had a supercomputer powerful enough to know the position and momentum of every single particle in the universe at the moment of the Big Bang, you could, in theory, calculate every single thing that would ever happen, including every thought you would ever have and every choice you would ever make. In this view, which aligns with the block universe theory, your feeling of making a choice is just an illusion. You were always going to choose the coffee over the tea, not because you freely decided, but because the intricate web of genetic predispositions, past experiences, and environmental factors, all tracing back to the beginning of time, made that outcome inevitable. Your consciousness is simply witnessing the unfolding of this predetermined causal chain. On the other side is the deeply ingrained, powerful intuition of free will. We feel like we are the authors of our choices. When you decide what to say next, it feels like you are genuinely selecting from a range of open possibilities. Some argue that the fuzzy, probabilistic nature of the quantum world might break this rigid chain of causality. Perhaps there are moments of true randomness in the universe that allow for genuine freedom. Others argue that consciousness itself is a force that can operate outside of simple cause and effect, allowing us to make choices that are not merely the result of prior conditions. This debate is not just an abstract philosophical game. It lies at the heart of our systems of morality and justice. If we are just puppets of causality, can anyone truly be held responsible for their actions? The question of whether time is an open road of possibilities we create with our choices, or a closed track we are destined to follow, remains the ultimate mystery of the human condition.
The fear of immortality, when forever becomes a cage. For most of human history, the ultimate dream has been the conquest of death, the fantasy of achieving immortality. We tell stories of fountains of youth and elixirs of life, imagining a future free from the constraints of our own mortality.
But as we've explored the vast and often terrifying nature of time, a different question arises. Is immortality a dream, or would it be the ultimate nightmare? What would it actually mean to live forever? At first, the possibilities seem glorious. You would have endless time to learn every language, master every instrument, read every book, and travel to every star. You could watch civilizations rise and fall, witness the slow dance of continents, and see the very evolution of life on Earth. But as the centuries stretch into millennia, and the millennia into eons, a profound and terrifying weariness might begin to set in. You would watch every single person you ever loved grow old and die again and again. Every friendship would be temporary, every connection doomed to end in loss. The very concepts of urgency, purpose, and achievement might lose all their meaning. Why finish a project today when you have 1 billion years to get to it? The weight of infinite memory could become an unbearable burden. How could a mind contain the grief of millions of lifetimes? The writer Jorge Luis Borges explored this in his story The Immortal, where the immortals, having done and seen everything, fall into a state of apathetic stupor, becoming like stone dogs. The fear of immortality is the fear that time, without the defining punctuation of an ending, would become a cage. It suggests that our mortality, the very fact that our time is finite and precious, is what gives our lives shape, meaning, and value. The deadline of death is what forces us to make choices, to form deep bonds, to create and to cherish the fleeting moments of beauty in a temporary world. In a universe of endless cycles and unimaginable timescales, perhaps the greatest gift is a single, finite, unrepeatable life. Time loops in fiction, what they teach us about ourselves. The concept of being trapped in a repeating loop of time has become a powerful and popular trope in fiction, from the movie Groundhog Day to shows like Russian Doll. In these stories, a character is forced to relive the same day or the same event over and over again. Everyone else is an unwitting participant, their memories resetting with each loop, while the protagonist is cursed or blessed with the memory of all the previous iterations. This narrative device is more than just a clever plot gimmick. It is a powerful laboratory for exploring the human condition. Stripped of a future and a past, the character is forced to live entirely in an intensified now. At first, this is often treated like a playground. The protagonist explores the hedonistic freedom of a world with no consequences. They can do whatever they want, knowing that everything will reset in the morning. But this freedom quickly sours, turning into a despairing existential prison. The meaninglessness of their actions becomes an unbearable weight. The true story of the time loop always begins when the character realizes that even if they can't change the events of the day, they can change themselves. They start to use the infinite repetitions to learn, to grow, and to connect with others. The loop becomes a tool for achieving a kind of perfection, not of the day itself, but of their own character and empathy. These stories resonate so deeply because they are a metaphor for our own lives. We often feel stuck in our own loops, the same routines, the same bad habits, the same recurring arguments. Time loop fiction
teaches us that the only way to break the cycle is not by trying to change the world around us, but by changing our own perspective and our own actions within it. It suggests that true escape from a temporal prison comes from finding meaning and connection in the very moments we are forced to repeat, transforming a curse into an opportunity for profound growth.
Temporal bias. Why we cling to a familiar past. Our relationship with time is not neutral. We have a powerful and often irrational set of biases that shape how we feel about the past, present, and future. One of the most significant is our temporal bias, which describes our tendency to view the past with a sense of stability and familiarity, while viewing the future with anxiety and uncertainty. We know the past. We have survived it. Its stories have been written, its dangers have been navigated, and its outcomes are known. This creates a psychological safe harbor. Even if the past contained difficult or traumatic events, it is a known quantity. The future, on the other hand, is a vast, open, and unknown territory. It is filled with potential threats, unforeseen challenges, and the terrifying possibility of failure. This is why, as a species, we often exhibit a strong status quo bias. We prefer to stick with what we know, even if it's imperfect, rather than risk a change that could lead to a worse outcome. This bias can be seen in everything from personal life choices, where people stay in unfulfilling jobs or relationships out of fear of the unknown, to societal politics, where appeals to a golden age in the past can be far more powerful than promises of an uncertain future. This bias is deeply rooted in our evolutionary history. For our ancestors, predictability meant survival. A familiar path was safer than an unexplored one. But in our modern, rapidly changing world, this bias can become a trap. An over-reliance on a familiar past can prevent us from adapting, innovating, and embracing the necessary changes that the future demands. It can lead to a kind of societal nostalgia that idealizes a past that never truly existed, while simultaneously fearing a future that is rich with possibility. Understanding this bias is the first step toward overcoming it, allowing us to look at the timeline of our lives with a more balanced perspective, learning from the past without being imprisoned by it, and engaging with the future not with fear, but with curiosity and courage.
The human desire to freeze perfect moments. Have you ever had a moment so perfect, so filled with joy, that you wished you could just press a pause button and live inside it forever? A beautiful sunset, a shared laugh with a loved one, a feeling of profound peace. This deep, universal human desire to freeze time reveals a fundamental tension in our relationship with it. We exist within a relentless, forward-moving torrent, yet our hearts are constantly longing for permanence. This desire is the driving force behind so much of our culture and technology. The invention of the photograph was a monumental step in this quest. For the first time, we could capture a fleeting instant of light and shadow and hold it in our hands, creating a tangible artifact of a moment that was gone forever. Today, our social media feeds are vast, curated museums of these frozen moments.
the perfect meal, the happy vacation, the smiling family portrait. We are desperately trying to build a fortress of perfect memories to shield ourselves from the anxiety of time's passage and the inevitability of change and loss. But this desire also contains a paradox. The very act of trying to freeze a moment can sometimes remove us from the experience of living it. The person who is so focused on getting the perfect picture of the sunset can miss the feeling of actually watching it. Furthermore, the beauty of these perfect moments is often inseparable from their fleeting nature. A beautiful flower is beautiful in part because we know it will eventually wilt. A shared laugh is precious because it is a spontaneous and temporary eruption of joy. If we could actually freeze these moments, would they retain their magic? Or would they become static, lifeless exhibits? The desire to freeze time is a poignant expression of our struggle against impermanence. It shows our deep love for the experiences of our lives, but it also highlights the essential truth that we must learn to find beauty not in permanence, but in the flow itself, embracing the bittersweet reality that the most precious moments are the ones we can never hold on to. Nostalgia, the sweet ache of a time that never was. There is a unique and powerful emotion that is intrinsically tied to our perception of time: nostalgia. The word itself comes from Greek roots, nostos, meaning homecoming, and elgos, meaning pain or ache. For a long time, nostalgia was considered a medical disease, a form of melancholia that could be debilitating. Today, we understand it as a complex and often bittersweet emotional experience. It is a sentimental longing for a past that we remember with fondness. But here is the crucial mystery. The past we are nostalgic for often never existed in the way we remember it. Our memory is not a perfect objective recording device. It is a creative and reconstructive artist. When we look back, our minds tend to smooth over the rough edges of the past. We forget the boredom, the discomfort, the minor anxieties, and we selectively amplify the moments of warmth, joy, and connection. We curate a personal golden age from the raw material of our own history. This is why the summers of our childhood feel endlessly sunny, why the music of our youth feels more authentic, and why the world seemed simpler and better back then. Nostalgia is a psychological comfort mechanism. In times of stress, uncertainty, or loneliness in the present, our minds retreat to the idealized safe harbor of our reconstructed past. It can provide a sense of continuity and identity, reminding us of a time when we felt secure or happy. However, this sweet ache also carries a subtle danger. An overindulgence in nostalgia can become a form of escapism, preventing us from engaging with the challenges and opportunities of the present moment. It can make us resistant to change and overly critical of the modern world. It is the perfect example of how our consciousness does not simply perceive time, but actively shapes and edits it. The past is not a fixed country we can revisit. It is a story we are constantly telling ourselves, a story that says more about our present needs and longings than it does about the objective reality of what once was. Nostalgia is the sweet, sad proof that we are all time travelers in our own minds, forever polishing the artifacts of a home to which we can never truly return.
Overthinking, the mental prison of past and future. If nostalgia is a gentle retreat into an idealized past, overthinking is a frantic and exhausting imprisonment within it. Our unique human ability to mentally time travel, Chronesthesia, is a double-edged sword. While it allows us to learn and plan, it also allows us to become trapped in endless repetitive loops of thought about the past and future. This is the state of rumination or anxious worry. When we ruminate, we are mentally stuck in the past. Our minds become a courtroom where we are both the prosecutor and the defendant. We endlessly replay a mistake we made, a conversation that went wrong, or a moment of embarrassment. We analyze every detail, searching for what we could have done differently, trapping ourselves in a cycle of regret, guilt, and self-criticism. We are trying to use the present moment to fix a past that is, by its very nature, unfixable. On the other hand, when we worry, we are mentally stuck in the future. Our minds become a relentless simulation engine, but one that is programmed to generate only the worst-case scenarios. We catastrophize about what might go wrong in a job interview, what could happen on an upcoming trip, or how a relationship might fail. We live out 1,000 potential tragedies before they ever happen, experiencing the emotional toll of failures that are purely imaginary. In both cases, the result is the same. We are robbed of the only moment that is ever real, the present. Overthinking is the ultimate temporal prison built by our own minds. It demonstrates how our advanced consciousness, our ghost in the machine, can become disconnected from the reality of time's flow. It highlights a central challenge of being a sentient being, learning to use our powerful capacity for mental time travel as a tool, a compass for learning and planning, without allowing it to become a cage that locks us away from the richness of life as it unfolds, moment by precious moment.
Can consciousness exist without time? We have spent this entire journey exploring the relationship between consciousness and time. But what if we ask the ultimate question? Is time a necessary condition for consciousness to exist at all? Our consciousness, as we experience it, seems inextricably bound to the flow of time. It is a stream of thoughts, feelings, and perceptions, one following another in a coherent sequence. Our sense of self, our personal narrative, is built upon the foundation of memory, our past, and our anticipation of the future. Without this temporal dimension, what would be left? Imagine a state of pure being with no before and no after. There would be no memory, because memory requires a past to refer to. There would be no anticipation, because anticipation requires a future to project into. There would be no sense of growth, change, or learning, as all these concepts depend on a sequence of moments. Could an awareness exist in a single, frozen, eternal instant? Some spiritual traditions and philosophical schools of thought suggest that the answer is yes. Mystics from many traditions speak of achieving a state of timeless awareness, a profound sense of unity with a reality that exists outside the flow of moments. In these states, the I that is built on a personal history dissolves, and what remains is a pure, undifferentiated consciousness. From a physics perspective, this question also has resonance. If the block universe theory is correct, then all of time exists simultaneously, and our consciousness is merely a spotlight moving through it. Could that spotlight, in theory, just stop and perceive an entire life or all of history in a single timeless flash? We have no way of knowing for sure. This question marks the very boundary of our understanding, where physics, philosophy, and spirituality all converge on the same incredible mystery. It forces us to consider that our entire experience of reality, this rich, flowing, time-bound life, might just be one specific mode of consciousness, and that beyond the shores of our temporal river lies a vast, timeless ocean of pure being that we can barely begin to comprehend. Time as a mirror of death and the search for legacy. Ultimately, our obsession with time is an obsession with our own finitude. The constant, relentless forward march of the clock is a constant reminder of our own mortality. A baby is born, grows into a child, then an adult, then grows old, and then is gone. This is the fundamental, inescapable arrow of time for every living thing, and it is this awareness of our own limited time that fuels one of the most powerful of all human drives, the search for legacy, the desire for a form of immortality. If we cannot live forever, perhaps a part of us can. This search takes many forms. For some, it is biological. Having children is a way to project a part of oneself, one's genes, one's values into the future, a way to ensure that the story continues after one's own chapter has ended. For others, legacy is creative or intellectual. An artist, a writer, a scientist, or an inventor hopes that their work will outlive them, that their creations will continue to inspire, entertain, or inform generations they will never meet. The great pyramids of Egypt, the epic poems of Homer, the scientific theories of Newton, all are powerful monuments against the erosion of time. Legacy can also be found in impact. A teacher who shapes the minds of their students, a leader who builds a just society, or simply a kind person whose acts of compassion ripple outward in ways they can never fully know. All are ways of leaving a mark on the timeline that extends beyond one's own lifespan. This profound human need to cheat death, to leave an echo that will not fade, shows that we see time as both our enemy and our canvas. It is the force that will inevitably erase us, but it is also the very medium in which we can create something of lasting value. Our entire civilization, with its art, its science, and its history, can be seen as a grand collective effort to shout into the abyss of time, "We were here." Final reflection. If time isn't real, what is? We began our journey with a simple feeling, a glitch in the matrix called déjà vu, and we have traveled to the very beginning and the ultimate end of the universe. We have seen that time slows with speed, that it bends with emotion, and that our past may only become real when we look at it. We have explored theories that suggest our universe is a hologram, a simulation, or a timeless, frozen block. We have seen that at the smallest scales, time may dissolve into chaos, and that the greatest minds in history, from ancient philosophers to modern physicists, cannot agree on what it truly is. So, after all of this, we are left with the final, most profound question. If time as we perceive it, this steady, linear, forward-flowing river, is a powerful and persistent illusion, then what is truly real? Perhaps what is real are the connections between things,
Not the sequence of events, but the web of relationships. Quantum entanglement suggests a universe that is deeply and spookily interconnected, where separations in space and time are not as fundamental as they seem. Perhaps what is real is consciousness, the possibility that the universe only solidifies into a definite reality when it is observed, places our awareness at the very center of creation. Maybe the cosmos is a story that requires a storyteller, a song that requires a listener. And perhaps what is most real is change itself. Not change in time, but change as the fundamental process that creates our experience of time. The universe is not a static thing. It is a dynamic, evolving process. The flow we perceive as time might be our most direct experience of this fundamental cosmic unfolding. We may never have a final, single answer to the question, what is time? But the journey itself, the very act of questioning, has revealed the true nature of our place in the cosmos. We are temporal beings, born of a mysterious past, living in a fleeting and precious present, and looking out into a future of infinite possibility. We are the universe's way of thinking about itself, the ghosts in the machine, trying to understand the clock. And that, perhaps, is the most real thing of all.